Hello everyone, welcome to my channel after a long time. And from now, I am going to start a BEE series. And in this video, we are going to learn about electrical circuits. So firstly, we have to know about network elements. Here you have two network elements, that is circuit and network. Now let us come to know what is meant by a circuit and what is meant by a network only having passive element, that is which is having no connection source, it is said to be a network. As if you see this network, here you have only resistors involved, and here you don't have any connection source, like a connection source in the sense like an active element, which is nothing but like a battery. In this circuit in this network we doesn't have any batteries, no. So it is said to be a network is nothing but only having a passive element, that is without having any connection source. And now coming to this circuit, so for this circuit, definitely it should contain a source, that is active element. Active element is nothing but it should contain a source like a battery. Here we have battery, so it is said to be a circuit. And here is an important point to note: all circuits are network, but it is not vice versa. That is, we can consider all circuits as network, but not network as a circuit, because in network here we don't have any active element, but in circuit it must contain an active element, then only it is said to be a circuit, right? So all circuits can be also known as the network, that is all circuits are network, but not vice versa. Hope you have understood. And now coming to this examples of network, as we have discussed previously, resistor, inductor and capacitor comes under the network. And now let us go through detail about this resistor, inductor and then capacitor. Here resistor is nothing but a energy dissipating element, which means that it will completely releases energy. See, remember one thing, resistor will never stores energy, it continuously dissipates energy. That means it will completely release that energy. And the property of this resistor is said to be resistance. And here we define this resistor in terms of, that is by using Ohm's law. What is Ohm's law? At constant temperature, current flowing through a conductor should be directly proportional to the voltage, that is potential difference across its end. Here we define as I is directly proportional to V, but not as V is directly proportional to I. We can define in such way also, but there is a specific reason why here we are defining as I is directly proportional to V. We'll come to know about it in the coming next few seconds. Now this Ohm's law, at constant temperature, current which is flowing through a conductor is directly proportional to the voltage, which is, that is the potential difference across its ends. Okay, see here, voltage depends on electric field and current depends on voltage. That is why we define as I is directly proportional to V, that is current is directly proportional to the potential difference across its end. Hope you have got it. And when the voltage is consumed, then only we'll get current. Okay, and since from this relation, that is I is directly proportional to V, we can write as I is equal to R, V is equal to I into R. This is Ohm's law, that is V is equal to IR. From here we can conclude that I is equal to V by R. Here you can know that whenever your denominator is less, then this term which is here will be higher. That means when your resistance is low, your current will be high, and whenever your current is low, your resistance will be high. That is, current and resistance are inversely proportional to each other. And now coming to this power, here you have to remember one thing, that only when the circuit is loaded, in that case only the power is consumed, and the rate at which the energy is consumed is said to be power. And here you have two formulas to remember, that is power is equal to voltage multiplied by current, and also power can be defined in terms of energy as power is equal to energy by T. Here W is nothing but your energy. See, only when your circuit is loaded, then only, right, power is consumed. If it is not loaded, then half this power is consumed. That means only when the circuit is loaded, power is consumed. That means the rate at which energy is consumed is said to be a power. And now coming to this energy. What is energy? As we all are familiar with this definition, that energy is capacity to do work. And the unit for this energy is kilowatt per hour. And the formula for this energy, which is nothing but V into I into T. From this relation, we can write energy as power into time. And since we know that power is equal to V into I, now your energy is equal to V into I into T. And here is just a simple example that, for example, if a classroom consists of 10 fans, and if each fan consumes a 40-watt power, then your total will be 400 watt. And since your college will be for 7 hours, let us suppose, then it will consume 2.8 kilowatt hour. This is just an example. Why do we use this energy, this formula? So for that, this example is given. And if a classroom consists of 7 lights and each one consumes of 100 watt, then it will totally become 4.9 kilowatt hour, and the energy consumed by this fans and light will be equal to 7.7 kilowatt per hour, which is this can also be written in terms of electrical units. This kilowatt hour is also said to be electrical unit. So 7.7 electrical units. That means approximately in a classroom, like nearly 8 electrical units are consumed. And here, when temperature does not remain constant, in such case we will define this resistance as RT is equal to R0 into 1 plus alpha into delta T. Here your R0 is nothing but absolute zero. Absolute zero, you have heard about absolute temperature. What is meant by absolute temperature? The temperature which is measured on the Kelvin scale is said to be an absolute temperature. So in the same way, here absolute zero, here its temperature should be 0 Kelvin, which is nothing but minus 273 degrees Celsius. And here your delta T, which is nothing but your temperature difference. And remember, for any problem, R0 and alpha remains fixed for a given material. And here your alpha is nothing but the temperature coefficient of resistance. And here your alpha is positive for a conductor. And if in the case of the conductor, if temperature increases, then resistance also will increase. And alpha will be negative in the case of semiconductor. In the semiconductor, current will rise sharply. And now coming to this, till now we have discussed about resistor, and now we are going to this inductor. So here we have gone through this resistor. It is an energy dissipating element. That means it completely releases energy. But now coming into the case of inductor, it will not dissipate energy. It will store energy. It will store energy in the form of half Li square. Okay, this is your inductor. And this Faraday law, that is flux per turn is directly proportional to the current flowing through the coil. Here this flux, which is nothing but your magnetic flux around the coil. And for this, here you have a derivation that this is for flux per ton. If there were n turns, then n phi is directly proportional to current, right? So let us suppose this as a lambda, and sometimes we often describe it as with a psi. And now your n phi will be equal to Li. Here your L is nothing but inductance. From this you get the formula of inductance as L is equal to n phi by I. If you want to write in the term like a definition, the ratio of total magnetic flux to the current is said to be inductor. And see, since you know that n phi is equal to Li, and as we all are familiar with differentiation. Now, since your n is constant, your n will get out, and d phi by dt, that is n into d phi by dt, which is equal to L into di by dt. This is nothing but E. E is nothing but your induced EMF. So, L into di by dt, which is equal to n into d phi by dt, which is equal to E. Let us suppose it as VL, that is like voltage. Now your di by dt can be written as VL by L. Now to get I, we have to make integration, right? So I is equal to 1 by L integral of VL into dt. Here your I is nothing but the current flowing through this inductor. And now coming to capacitor, and this is the last topic, and in next video we will go through this Kirchhoff laws. And this capacitor, and now coming to this capacitor, two separate parallel plates are separated by a dielectric in the case of this capacitor. And this capacitor, in these also energy is stored. It will not dissipate energy. It will store energy in the form of half CV square. And now coming to this, Q is directly proportional to V, that is charge is directly proportional to voltage in the case of capacitor. And by removing this proportionality constant, we can write as Q is equal to CV, and by differentiating this, that is dQ by dt is equal to C into dV by dt. And this I, we know that dQ by dt is nothing but your current, which is current is nothing but the charge upon the time taken. So that will be your I, that is IC, that is current flowing through capacitor, right? So IC is equal to dQ by dt, which is equal to CV by C into dV by dt. Now your C into dV by dt, which is equal to IC. And in order to get VC, we have to make integration again, dV by dt, which is equal to IC by C. And then by integrating this, we get dV is equal to IC by C into dt, right? So VC is equal to 1 by C, since your C is constant here, integral IC into dt. And this table is summary of this resistance, inductance and capacitance. Hope you have understood this topic, and if you have any doubts regarding this topic, feel free to ask me in comment section, and definitely I'll respond to each of your doubts. Thank you for watching, and subscribe my channel for more videos.